The graph you see depicts some of our data points. Now we have cups up to 15 cups. We have depths going from approximately 40 to 60 centimeters at more or less a constant scale, 40 here, 50 here, 60 here. Actually 40 is maybe a little too high, and that's going to affect the linearity of the graph. The data that we obtained were for we got 3, 6, 9, 12, 15 cups marked along this axis. And we have data points. The first data point says that the reading on the meter stick at the point on the spring where we read it was 44.7 centimeters. At 6 cups we got 47.8 centimeters. At 9 cups we got 52.3 centimeters. 12 cups 57.2 centimeters. 15 cups 61.7 centimeters. The meter stick was pointing down. 100 centimeters was closer to the floor than the 0 centimeters. That's just the way the meter stick happened to go when I set it down. Didn't really care whether it went one way or the other. Okay, when we plot these points, one way to check whether they form a straight line, it seems that they're maybe tending to curve up a little bit, but that could just be the way I marked the scale in the graph. This freehand graph isn't real accurate. We calculate the average slope between points. Between 44.7 and 47.8 we have an increase of 3.1 centimeters, so the rise here is 3.1. The rise here is 4.5 from 47.8 to 52.3. Then we have a rise of 4.9, and finally from 57.2 to 61.7 a rise of 4.5. We see that except for the first rise, these rises seem to be reasonably consistent. It goes up a little bit, down a little bit. In the process of obtaining the data we noted two things. One, things didn't tend to change by the same amount every time, or they didn't change by the same amount every time, but sometimes it was a little more, sometimes a little less. There was some friction involved, and the thing just came to rest at positions that weren't exactly where they would ideally come to rest. But on the whole, we did have about the same average change in position of the spring after the first few readings. The first few readings there wasn't much change, and then all of a sudden it started changing pretty consistently. So if we assume that these 4 points here and are a good model of what the spring was doing, and if we discard this first point, we can attempt to fit a straight line to these 4 points. Now we actually took a bunch more points. We just have every third point plotted here to give us a general indication. But what we're going to do is we're going to plot a straight line that comes as close as possible on the average to these points, and then see what we can find out about the equation of that straight line.